In this video, we'll go over nuclear reaction and focus in on positron emission. Nuclear reaction occurs when there is an unstable nucleus within an atom and it wants to relieve itself so that it will become stable. And so one particular nuclear reaction for any atom to go through because of this instability is called the positron emission. Now there's alpha, beta, gamma, electron capture, but the focus of this video is on the positron emission. In the positron emission, there is a change within the nucleus where a proton will change so that it becomes a neutron. And as it's doing that, there is a particle, a positively charged particle, or also known as the positron, that will come out. Now, you can denote it as this example, like this fluorine 18 isotope, okay? The fluorine 18 isotope forms into oxygen because there is a change in the number of the proton from 9 to 8. One of the proton has been lost. That's because the proton changed into a neutron. As it's doing that, there is a particle that has been emitted. Now, this emission or positron emission, you could denote it as beta, 0 and plus 1. Or you could denote it as this, where you have an electron-like particle, but they're in a different charge. So hence the positron, not electron, right? Now, positrons are positively charged, like I have mentioned, and they have very little mass. This is an opposite of what's happening is sort of in beta decay. They don't have a E plus 1, but they have an E negative 1 that's coming out. If you don't understand what I'm talking about, maybe you might want to check out the beta decay video after this. Now, the positrons are generated when the proton decays into a neutron, as I have mentioned, and it also decays into positron. This occurs when there are too many protons and too little neutrons. So if you have an N to Z or neutron to proton ratio, you'll notice that because that the proton is high and the neutron number is low, you might get a small value. I'm going to quotate small, and so probably less than 1. Okay, less than 1 is what you're going to see in this ratio. So when there is a less than 1 ratio or relatively small, you might see that you might see that atom going into a positron emission. So let's do a learning check. Here it says phosphorus 30 is going through positron emission. Okay, let's go ahead and show that. And so here's my phosphorus 30, and it's going to go into this direction, and where in which beta plus 1, 0 has been emitted. As it's doing that, we form into another element. What's the other element? Well, let's figure out the mass number and the proton number to get what the other element might be. On the left side of the equation, the mass number, the only thing we can look at is this 30 from the phosphorus. By the way, that's the mass number. That corner is the mass number, and this corner is the proton number. We know phosphorus has an atomic number of 15. That's because proton, there's only 15 protons. All right, so the proton number is 15. On the product side, the mass number and the proton number, the summation of it, whatever you add all together, should equal out to 30 and 15 mass to proton respectively. Since we have 0 mass for the beta, so we'll put 0 plus what needs to be the here in this area to make it equal 30. Hopefully you were able to easily find that out, which is 30. So what that means is 0 plus 30 is 30. This right here, 30, is the 30 that I should see in the other element that the phosphorus turned into. Also, the proton, well, we have a plus 1 from that positron emission, and so plus what equals 15? It's 14. So go ahead and look in your periodic table what number falls under 14, and you'll notice that it is silicon, Si. So that's how I was able to get Si. I knew what these are first. Then from the proton number or the atomic number, we can get what element that might be. So silicon. Go ahead and try for magnesium. You can show it by looking at the mass and the proton number, 30, 30, 15, 15. And for this one, it will be 23, 23 as the mass number. And magnesium has a proton number of 12. And so on the right side, totality should be 12. Try this and come back. And here is the key.